Hello guys, welcome to Maths and Physics Catalyst channel. If you are here for the first time, subscribe to my channel, like and comment with your problem. Share it to colleagues so that they will benefit also. This is our first topic in advanced class, which is the functions. So functions is under calculus because it is functions that will lead us to differentiation and integration, which we know as derivative and antiderivative of a function. So now, these are the things that we will cover in this chapter. First, we are going to study the introduction of the functions, the types of the functions, domain, codomain, and range of the function. Okay, let us start with the introduction of a function. What is function? What did we mean by function? So basically, it is not only in mathematics that we have function. Yes, in real sense, we have been dealing with functions, but we don't know. For example, let's say you are pressing your phone, and once you press, let's say, a letter in it, that letter, if you press M, for example, what will appear in your keyboard is M, not N. Why? Because that M you press, it is just the input. It is an input. You are trying to insert an input of a command or relation, which after that M appeared in your screen. This means that M you see in the screen is the output of what you press. Did you understand what I'm trying to say? Let's say whenever you give a command, or let's say your calculator, if you press 2 plus 3, that 2 plus 3 are the inputs you are inserting. Now there will be execution of some commands. You just say 2 plus 3, that plus is command. You are saying 2 in addition with 3, and then what will happen? The output will come in your screen, output of 4, for example, and that is the output. So all these examples are examples of function. Function is nothing but a system of relation or laws which has input and what? An output. That is function in a real sense. So now, in mathematics, functions are basically represented by this. This is the name of the function, f of. So if I put something here like x is the input. So this function is f of x, which means function of x. Now, this function is such that x is mapped on some variables. These are outputs. It means whenever I insert x, then x will be processed and result y. So generally, this is the definition of the function. This one is the name of the function. This one is the input of the function, and this one is the output of the function. So a function is nothing but a set of rules, laws, or relationship between two variables. For example, let me give us example of functions. For example, we have f of x is equals to x plus 1. This one is a function because f of x is the name of the function, x is the input of the function, and here is the variable. So this one is the relationship. It's the relationship or the law of the function. What's the law here? The law is whatever is the input, you are commanding it. Whenever is the input, add 1 to it. Then it will become what? Your output. So if we try to input f of 0 in the function, what will happen as the result? It will be 0 plus 1, and it will be equals to 1, which means our output is 1. When we press 0, if it is 0, what will be assigned or will be marked in the output is 1. I hope you are getting what I'm saying. For example, let me give another example of function. Let's say f of x is equals to square root of x. This function is what is typically in our calculators, because it is saying whatever you insert as x and you put it in this function, it will evaluate square root of x. For example, if I now try to evaluate what is f of 2, f of 2 will just be square root of 2. If I try to evaluate what is f of 4, f of 4 will be square root of 4. and we know that square root of 4 is 2. I hope you are getting what I'm saying. So now all these are a kind of examples of what? Of function. For example, this function f of x is equals to x squared. This function also has its own rule. The rule said whatever is your input, take it, multiply it by itself, that is the square, and then generate the result. For example, if I try to find what is f of 1, it will now say 1 square and is equals to 1. What is f of 2? It will just say 2 squared and is equals to 4. As you can see, generally, function is nothing but a set of relationship or rule which relate the what? The input and the output. That is the function. So now, here, as I said, this one is the function name, f of x, while this one is the input of the function. This one is the output of the function. So we can explain this in terms of what we said, we call them domain and range, which we are coming to it. So okay, this is about the function. Now let us go to types of function. In the types of function, generally we have so many types of function because there are many, but let me give us some. For example, a polynomial function. A polynomial function. What is polynomial function? Polynomial function is just a function which is generally in this format. If the function is function of x, it will just be ax. A is a constant number, x is the variable of the function, and now this a will be of n. That is for whatever is the power here. What I'm trying to say here is just this one can be a1, a2, a3 or something like that, and the power can be power 1, power 2, power 3. So generally it will be an, the next term will be an minus 1, and here will be x power n minus 1, plus the next term will be an minus 2, here will be x power n minus 2, plus dash 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 up to what? Up to the last term. Which one is the last term? This, up to a naught. That is the constant term, the term which is independent of x, or we can say a x raised to the power of 0, because x power 0 is 1. This is generally the terms of polynomial. So in case a polynomial has highest power, because n is the number of power, if it has highest power of 1, in that case we call it linear. If its highest power is 2, we call it quadratic. So if it is above 2, 3 or any power, we can call it a polynomial function. Example of this polynomial function is this: x squared plus 5x plus 6. This one is what? Polynomial expression. Once I said this is equals to f of x, now it is a polynomial function. Let's see, I say this, f of x is equals to 6x power 5 plus 5x squared plus 3x minus 5. This one is also a function. And also, if I see this one, f of x is equals to 2x minus 1. This one is also polynomial function. So any kind of function that you see in this format, it is polynomial function, and it is among the types of function we have. Now, the second type of function we have is the trigonometric function. The trigonometric functions are those functions which are periodic. They always change with the same factor or the same angle. They move continuously. If you plot it, they will go continuously, except if you are given a certain range. For example, if you have this, f of x is equals to sine x. Sine x itself is a trigonometric function. Or you have f of x equals to cos x or tan x. All this, they are trigonometric functions, and they have their own inverse and the other trigonometric functions, like what? Like the sec or the cosec or the cot. I hope we understand. So all expressions of functions in this format are what? They are the trigonometric functions. For example, you can see a function f of theta is equals to sine squared theta minus cos theta. Of course, this one is trigonometric function. Yes, because it has sine, cos, or tan. I hope we understand. And all the examples which resembles this, they are all what? Trigonometric functions. After trigonometric functions, we can also have another types of logarithmic functions. Logarithmic functions. So logarithmic functions are just functions of logarithm, and we know that logarithm, it can be either of natural logarithm or normal logarithm. For example, we can have this logarithm of x base b. This one is the true logarithm in terms of the number. For example, you have log x base 2. This one is also a function, is function of logarithm when you have a base of number, either base 10, 1, or base 2, 3, or 10. But now, if we have this, for in case of natural logarithms, natural logs, this is where we have logarithm of a number, but the base is always the exponential. That is the natural log, and it is normally written as ln of x. Logarithm of x, the base of what? Exponential, where exponential is just a constant number. So this one is also what? A function. It is called logarithmic function or functions of logarithm. For example, you see this f of x is equals to 2 log x minus 3 ln x, and here it happens to be like this. So this one is function which comprises logarithm, which means it is function of logarithm. I hope you understand. Now we have other functions like even the exponential functions. So what are the exponential functions? Exponential functions are just functions of exponential. They are generally in this format: f of x is equals to a exponential ax. This is their format. That is, f of x equals to a number, exponential, another number as coefficient of the power, and we have x. For example, let's say we say this f of x is equals to 3 exponential 2x minus 5 exponential x. This one is function of what? Exponential functions. As I said, this one, there are what? Polynomial functions. We see the example: trigonometric functions, logarithmic function, and exponential functions. Okay, there are some another examples of functions. We have the hyperbolic functions. We have hyperbolic functions, where hyperbolic functions are when f of x is equals to either sinh x or cos x or tang x. This one. So they resembles trigonometric functions. They always resembles trigonometric function. For example, you see f of x is equals to 3 sinh x minus 2 cos 2x plus 5 tan x, something like this. So these are the functions we have: polynomial functions, trigonometric functions, logarithmic functions, exponential, and the hyperbolic functions. So all these functions have their own characteristics, have their own inputs and have their own method of operations. Okay, now going back to our contents, what we have here is the domain, codomain, and the range of a function. Domain, codomain, and range. So generally, so my this lecture will just cover the domain, codomain, and range, their definition, and some little examples. Then in my next lecture, I will show us how to identify, evaluate, or find the domain, codomain, and the range of a function. Okay, now starting with this. Let's say we have a set of A variables. Let's say this set is A and it contains variables 1, 2, 3, and 4. There is what we call mapping in a function. How do we understand or guess or understand what is meant by mapping? It's just mapping is nothing but a value that is assigned for input, because we know that for any input there is value that is assigned for it. Do we understand? So that values, that assigned or representation of that diagrammatically is what we call mapping. So for example here, 0 and 1, they are mapped to each other. That is, 0 is mapped to 1. Like here, 2 is mapped to square root of 2. 4 is mapped to 2. I hope we understand. So if that's the case, let's say these values of A are now maps on values of B. Do we understand? But now there is a set C which contains all of them. This is set C, which contains all of them and some addition of extra numbers. So it happens to be a function. We have a function of A, such that A is mapped on C. That is, values of A can be mapped on the values of what? C. And then now we take these values of A, that is 1, 2, 3, 4. Okay, I'm sorry, let this one be 8, 7. This is just example. I just want to illustrate, because from this we can get the definitions of domains and range. Okay, so these are my inputs, which is A, while these are the outputs, which is B. The outputs are 5, 6, 7, and 8. As we can see, this is the function, because function is the relation. Function is always the relation. So we are saying whenever we put 1 in the function, it gives us what? 5. When we put 2, it gives us what? 6. When we put 3, it gives us 7. When we put 4, it gives us what? 8. This means the inputs in this function, let's say here in this set, what we are inserting inside the function are this: 1, 2, 3, 4. Those are the inputs. Those are what we are putting inside the function. So all these numbers that you are putting inside a function are what is called what? Are what is called domain of a function. Values you insert here. Like in this example, I put 0, then 0 is among the domain of the function. 2 is among the domain of a function. Domain is just a set which contains all the possible inputs that can be processed in the function and result output. As far as if I put a number, it will be processed and give a result as output, then that number is my domain. I hope you understand. Now, these are the numbers that I have. These are the true outputs that I have. When I put 1, I get 5. When I put 2, I get 6. When I put 3, something like this. So these true outputs gotten are called the range of the function. These are the range, those actual outputs you got from the relation. Let's say after all this are processed, you now have 5, 6, 7, and 8. Then those outputs are what? The range of the function. I hope you understand. So this means range is nothing but the set containing all the actual outputs. Do we understand? All the actual output processed by the function. Now, the codomain is nothing but that set which contain all the possible outcomes. Do we get the point? That set which contain all the possible outcomes. Let me just represent as C. As we can see, this set C contain all the possible outcomes of the set, all the possible results, because 8, 6, 5, 4 are inside it, and there is still some numbers. There are still some numbers 4, 3, 2, 1, which those numbers we don't have them here because we did not input their actual value, which it is mapped on them. Do you get the point? Maybe it is when I put 5 that I will get 2, but I did not put 5 here. Then that is why I did not get what? 2. Do we understand? Know that codomain is in the output. We are talking about output. That is why we explained the codomain. So it's just the set that contains all possible of the output, all possible values. Anything that we see is just the scope. If we want to represent this in set, if this is domain, this set is domain, then this set, the overall set, will be codomain. While inside codomain, that is where you will get a set range. Do you understand? So always all members of range are among the what? The codomain of a function. But the actual outputs of the function are those that are called what? The range. While the total outcomes, all the possible outcomes of the function are called what? The codomain. And those inputs are called what? The domain. This is about the examples of all the explanation of what? The domain, the range, and the codomain. And we have to know that there are some functions, because we said possible outcomes or possible inputs. Yes, there are some functions that it is not possible actually to find or to insert any number or some numbers, to insert some numbers in it, because we expect output in our input in order to make that function defined. As far as function is defined, for example, f of x is equals to 1 over x. Yes, this function is defined. It's a function with input x, and the relation or the command here is 1 over x. So now, if I try to put f of 1 in the function, when my domain is 1, the output of the function will be 1 over 1 and is equals to 1. This means, yes, 1 is among the domain. Since 1 is processed and the result output, which is range. My domain is 1, the range is 1. Now, when the function is f of 2, what happened? The function is f of 2, I will have 1 over 2. And 1 over 2 is always what? Is also a number which is defined. Then we now said what? 1 over 2 is the range, and what? 2 is the domain. It is also possible, and it is also what? Defined. Okay, now let us try when my input is 0. When my input is 0, I will have 1 divided by 0. And we have to know this. Always in mathematics, we don't need 1 over 0, because 1 over 0 is undefined, or here in advanced we call it infinity. It is infinity because infinity is not defined. Infinity, we just assume that it is a largest number, but it is not defined. This means 1 over 0 is something undefined. Since it is something undefined, this means this function at x equals to 0 is not defined. Do we understand? The result is not defined, means the input, the function at this input is also not defined, and which means 0 is not among the domain. 0 is not among the domain of my function. It's not among the domain, because domain are only those numbers in which if I insert them in the function, they will be processed and result output. I hope we understand. And there are so many functions like this. Let's say if we have f of x equals to 1 over x minus 1. This function is true for all value of x except when x is what? When x is 1. When x is 1, the function is not defined. This means x can never be 1, because once x is 1, the function will be what? It will be 1 over 1 minus 1, and which is 1 over 0. We don't need division by 0. This means this function is not defined and at x equals 1. But after 1, or in this case after 0, all possible inputs are true, because if I put 2 is correct, if I put 1, even if I put negative numbers, let's say here I put minus 1 will be true, because minus 1 is what? 1 over minus 1 minus 1, and it will be 1 over minus 2, which will be minus 1 over 2. Minus 1 over 2 is defined because it is negative number. It is negative number, so it is defined. I hope we understand. So the inputs of our functions are the domain. The outputs of our function are the range, while the set containing all the possible outcomes is what? Is the codomain. Thank you very much. We meet in our next class. Remember, if this is your first time of attending here, please subscribe, share it to your friends so that they will understand.